My name is Dan Covington. This is Skill Practice 42, and I'll be guiding you through the answers. So for this specific problem, you have to fill out the whole table, and how you can do this, I'll only show you one time for the time t equals 20 seconds, but anyway, uh, you look at the mole-to-mole ratio in the balanced equation that they give you, and then you also look at how much you start off with of moles of HSO3 minus and IO3 minus at time t equals 0. So the math you can see for HSO4 minus is 0.0021, which is the moles time t equals 20 times 3 equals 0.0063 moles, because it's a 3-to-1 mole-mole ratio. For IO3 minus, you look at how much you start out with of that, so it's 0.0105 minus 0.0021, and since it's a 1-to-1 mole-mole ratio, you don't multiply it by anything, you multiply it by 1, and that equals 0.0084 moles. Same thing with HSO3, except for you're multiplying the 0.0021 by 3, since it's a 3-to-1 mole-mole ratio. So for this one, you have to calculate the average rate of formation of I minus during each of the following intervals. So between 0 and 20, I thought of this more as like a slope problem, where you take y2 minus y1 over x2 minus x1. And however, you need to convert it into molarity first, but you're given the volume here, which is 0.45 liters, and you're given the moles in the table. So how you can fix this is 0.0021 divided by 0.45, which gives you the molarity, and so that's the y in this situation, and then you divide by the interval, which is 200 minus 0. Just wrote it here as 200, and then it ends up being 2.33 times 10 to the negative fifth molarities per second. Same thing with B. You take, but this time, instead of having 0 as your initial, you need to account for the other one. So you take 0.0032 divided by 0.45, that's your y2, and then minus 0.0021 divided by 45, that's your y2, and then divide by 400 minus 200. It's 200 for all three of these, and then you end up getting 1.22 times 10 to the negative fifth. Same thing for C. Just do it how you would, and you end up getting 7.78 times 10 to the negative 6. So for question 3, you just look at the mole-to-mole ratio to find the rate of disappearance, and it's 0.0045 for HSO3 minus, but since it's a 1 to 3 mole-to-mole ratio, you divide by 3, and you end up getting 0.0015 molarities per second. I hope this was helpful, and good luck.